All right, here is a great beginning of properties of exponents. This particular tutorial will be part 1 and part 2. There were actually 4 parts to this, so please make sure you watch the second installment, which has part 3 and part 4. But before we begin with part 1, let's make sure we have a quick review on exponents so we are using the same language. An exponent is a number placed above and to the right of another number to show that it has been raised to a power. So you've used exponents previously, so our base is the big number, the exponent is the raised power, and 2 to the 5th power means 2 times 2 times 2 times 2 times 2. There's 5 2's written here. So 2 to the 5th is 32. That's how we figure it out. You just multiply 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So we're ready for multiplication properties. Property number 1. It's called multiplying powers with the same base. This is why we needed to know what a base was. The base is the big number. We need to make sure we have the same base. To multiply powers with the same base, keep the base and add the exponents. All right, so what does that mean? So if I have 3 to the 5th times 3 to the 8th, it says if you have the same base, keep the base, so we're going to keep the 3, and add the exponents. 5 plus 8 is 13. So let's see if that's really true. Seriously, we just make this stuff up. 3 to the 5th means I have 1, 2, 3, 4, 5 3's. 3 to the 8th means I have 8 3's written out. And so if I have 3 to the 5th times 3 to the 8th, I'm going to actually end up with how many 3's altogether? 13. Not bad. So when we see it written as algebra, some students go, oh my gosh, I don't know what b to the m times b to the n is. Just means you have the same base. All you have to do is add whatever those numbers are. That's all it is. So here we go. Let's practice it. So we're going to multiply and write the product as 1 power. 6 to the 6th times 6 to the 3rd. Do we have the same base? Yes, we do. So we're going to add our exponents, and 6 plus 3 is 9. Not bad. Try it again. Oh, we're using letters. Yes, the letter n. N to the 5th times n to the 7th. Do we have the same base? Yes. So we just add our exponents. So we have n to the 12th. All right. 2 to the 5th times 2 to the... what exponent would be here? Yeah, 1, because we don't write an exponent of 1. So we have 5 plus 1, so it's 2 to the 6th. All right. 24 to the 4th times 24 to the 4th. Do we have the same base? We sure do. So same base means we add our exponent. So we have 24 to the 8th power. Go ahead and pause the video as soon as these two problems come up. Here we go. And I want you to work out 5 and 6 and then come back and check your answers. Okay, how'd you do? Did you get 8 to the 10 plus 3 plus 7? Did you get 8 to the 20th? I hope so. What did you do on number 6? Do they have the same base? No, they do not have the same base. So you can't do anything with them. Oh, I know that wasn't fair, but sorry. Some things aren't fair. Well, that was rule number 1. So exponents rule number 1 for multiplying. Now let's do multiplying rule number 2. This is called powers of powers with the same base. There is no quiz about what these rules are called. You just need to be able to do them. So here's what it looks like. I have 4 to the 3rd power, and I'm raising it to the 5th. So here's what we're doing. I'm taking 4 to the 3rd, which is 4 times 4 times 4. Correct? Do you agree? 4 to the 3rd means that. And I'm doing it how many times? Yeah, 5 times. So I have 3 4s, and then 3 4s, and then 3 more 4s, and then 3 more 4s, and 3 more 4s. How many 4s do I have altogether? Yeah, you may want to pause and count it up. I have 15 of them. I have 15 4s. So 4 to the 3rd raised to the 5th power is 4 to the 15th power. So what do you notice about that 3 and the 5? How did it make a 15? Yeah, multiplying. So the rule for multiplying, rule number 2 for exponent, the rule is that if you're taking a power to another power, you multiply the exponents. So 3 times 5 gives us 15. Not bad. All right. I know I'm jumping right into rule number 3. This is power of a product property. It's used when you have different bases being raised to another power. Let me just show you what it looks like. Okay, in this case, you're going to distribute the power to each base by multiplication. Okay, I'm just going to show you what it looks like. There we go. That's what I was waiting for. So notice I have 2 to the 3rd, m to the 5th, and I'm going to take that whole thing 4 times. It says distribute the power to each base by multiplication. That means I'm going to do 4 times 3 and 4 times 5. That's right. I'm going to take 2 to the 3rd to the 4th power and m to the 5th to the 4th power. So that's 2 to the 12th, because 3 times 4 is 12, and 5 times 4 is 20, and that's your final answer. All right, so basically you're distributing your exponent to everybody who's in parentheses. Everybody's getting a power of 4 by multiplication. Okay, so let's practice. Ooh, we get to practice rule number 3 right away. So everybody's going to get a power of 2. So I'm going to give the 3 squared a power of 2, and 2 times 2 is 4. And I'm going to give y cubed a power of 2, and 3 times 2 is 6. So I have 3 to the 4th, y to the 6th. Now, from here on out, unless it says to leave it as an exponent, leave it as an exponent. If 3 to the 4th is around 1,000 or less, you need to tell me what 3 to the 4th is. Do not just sit there and leave me 3 to the 4th. And I can tell you right now, 3 to the 4th is definitely less than 1,000. So make sure you do 3 times 3, that's 9, times 3, 27, times 3 is 81, y to the 6th. So if it's right around 1,000, that's my cutoff point for making students work on it. You know, what if we did 24 to the 8th power? That would be insane. Just leave it 24th to the 8th power. All right, number 2. Ooh, another one just like it. So we need to give everybody the 5th power. 5 to the 5th power. A squared to the 5th power. B to the 4th to the 5th power. So remember that exponent for 5 was 1, so 1 times 5. The exponent for A was 2, 2 times 5. The exponent for B was 4, 4 times 5. So we should have 5 to the 5th, A to the 10th, B to the 20th. And 5 to the 5th, I know what 5 times 5 to the 4th is 625. So if I do 625 one more time, I'm way over 1,000. So 5 to the 5th is just fine. Okay. Oh, see, I knew I was going to say something smart like that. All right, let's do it again. We need to give everybody in parentheses a power of 3. We're going to give that negative 4 a power of 3, 1 times 3. We're going to give that regular old x a power of 3, 1 times 3. We're going to give that y to the 3rd a power of 3. And so we end up with negative 4 to the 3rd, x to the 3rd, y to the 9th. And do you think negative 4 to the 3rd is less than 1,000? Oh, yes it is. It's going to be negative 64. Ding, 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 ding. Okay. Want to do it again? We're going to give everybody a power of 2. That's right. 2 to the 4th gets a power of 2. H to the 3rd gets a power of 2. K to the 2nd gets a power of 2. And you'll end up with 2 to the 8th, H to the 6th, K to the 4th. And do you believe 2 to the 8th is less than 1,000? It is. Good, that's the correct answer. It is less than 1,000. And it's 256, H to the 6th, K to the 4th. Okay. I don't know. I probably say okay too much. You're probably going, oh, please stop talking. Wow. All right, let's go back because that was the last one. Dun, 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 dun. Multiplication properties. Now, I'm going to tell you, these aren't that bad. And when we get here to the division properties, part 2, they're not bad either. It's when they're all on the same exact problem when things get rough. So let's just learn these individually, and then we're going to put them all together in the second presentation. Dividing rule number 1. Let's read it. To divide powers with the same base, keep the base and subtract the exponents. All right. So let's see what that looks like. So if I have the problem 6 to the 9th divided by 6 to the 4th, notice the base is the same. They're both 6's. It says to subtract. So that's 9 take away 4. That's numerator take away denominator. 9 take away 4 is 5. So let's just see if that's really true. So here's 6 to the 9th. And you write it out how many times? 9 of those 6's. And we're going to divide it by 6 to the 4th. So I have out 4 6's. Now let's just start reducing. There's 6 divided by 6 is 1. 6 divided by 6 is 1. 6 divided by that 6 is 1. And 6 divided by that 6 is 1. And how many are left in my numerator? That's right, 5 of them. So that's 6 to the 5th. So if we were going to write that in algebra terms, meaning with letters, that'd be b to the m to b to the n They're the same base, so I can subtract my exponent. And it's always numerator take away denominator. Muy importante. I mean, that means very important. Okay, let's practice. Now, this says divide, write the quotient as 1 power, meaning, if we don't care, we just want, we do care. That just means leave the answer with an exponent, don't solve it, okay? So I have 7 to the 5th, 7 to the 3rd, they're the same base, so we're going to subtract our exponent. The numerator take away the denominator, 5 take away 3 is 2. So 7 squared. You don't have to write 49 because it said write the quotient as 1 power, meaning leave it as an exponent. X to the 10th divided by x to the 9th. We have the same base. We subtract. 10 minus 9 is just x, because we don't need to write the 1. That's bad math grammar. You don't ever write the exponent of 1. It's assumed it's there. Okay. 9 to the 9th, 9 to the 2nd. So same base, subtract your exponents. 9 take away 2 is 9 take away 2 is 7. All right, let's do another one. Ooh, 4 to the 3rd divided by 4 to the 3rd. 3 take away 3 is 4 to the 0 power. So let's see here. 4 divided by 4, 4 divided by 4, 4 divided by 4 is, well, 1. 4 to the 0 power is 1. Does that mess with you? But look, 4 to the 3rd. Technically, 4 to the 3rd is 4 times 4, which is 16 times 4 is 64, which means your numerator is 64 and your denominator is 64. What's 64 divided by 64? 1. Anything. Any number to the 0 power is 1. Yeah, I'd write this down. Any number to the 0 power is 1. And so you would never give me an answer of 4 to the 0 power. You would automatically say the answer is 1. All right? If you even have 1,000 to the 0 power, the answer is 1. Because that means like 1,000 divided by 1,000 is not 0. 1,000 divided by 1,000 is 1. Okay, here are your 2 problems. Please pause the video at this time, work out your 2 problems, and then come back. We'll talk about the answers. Welcome back for number 5 and number 6. We do have the same base. Hopefully you subtracted your exponents and got e to the 5th. On number 6, I did not throw you off and give you different bases. We have the same base, 70. So we subtract our exponent, and we have 70 to the 12th power. Thank goodness we do not have to find out what 70 to the 12th power is. It's a monstrously huge number. Division rule number 2. The power of a quotient property has you distribute the power to every number inside the parentheses. Both the numerator and the denominator get the power. Let's see what it looks like. So if I have the fraction 2/3 to the 2nd power, and technically this is 2 divided by 3, hence the reason why it's a division rule, it says I need to give the numerator and the denominator the power. So I give the 2 the power, the 3 the power. That's 2 squared divided by 3 squared, which is 4 over 9. Can I reduce that? Nope, so it's 4 9s. So this is what it looks like. So when you have a division problem, I know, you're like, wait, that's a fraction. Fractions are just unfinished division problems. You're going to give the numerator the power and the denominator the same power. So let's practice. X over 6. What are we going to do with this 3? We're going to give it to everybody. X cubed over 6 cubed. Now, the rule comes back into play. Is this less than 1,000? Yes, say yes. It is. So our correct answer is x cubed over 216. Do it again. Whoa, I know I switched up my fractions here. 2m over 4 to the 4th power. We're going to give 2 the 4th power. We're going to give m the 4th power. We're going to give 4 the 4th power. Everybody's getting a 4th power. 2 to the 4th, m to the 4th, 4 to the 4th. All right, these look less than 1,000 to me, so start figuring them out. So we have 16 m to the 4th over 256. And yes, you'll have to reduce. And you have to reduce, and it goes down to 1/16. So we end up with 1/16 m to the 4th. So technically there's a 1 in the numerator over 16. Now some of you are going, wait a second. Look over here. Miss Johnson, this is a fraction 2/4. And 2/4 reduces to 1/2. You're right. If you wanted to reduce this fraction first, before giving everybody the 4th power, that would be a great shortcut. Totally agree with you on that one. I would do it. Okay, you have 2 practice problems. You are welcome to pause me right now, work on the 2 problems on your own, and then we can come back and talk about them. I will see you soon. Welcome back. Okay, we have negative 2 to the 3rd power, 3 to the 3rd power. Everybody's getting a 3rd power. And what is negative 2 to the 3rd power? Negative 8. And 3 to the 3rd power is 27. Can we reduce negative 8 27s? Nope. All right, here we go again. Oh, were you thinking about our last conversation about the 8 and the 2? You could probably reduce. If you didn't reduce right away, don't worry. We can give everybody a 3. We can do 8 cubed, b cubed, and 2 cubed. Because 8 to the third power is a beautiful number of 512. B to the third power and 2 cubed is 8. And just so you know, 8 does go evenly into 512. Goes 64 times, so it's 64b cubed. I really like reducing first. Okay, but it's okay if you didn't. All right, wow, that was it. So have fun with your division, with all of your multiplication properties and your, let's see, multiplication properties, division properties, all that good stuff.